All right, we'll just go ahead and get started. It breaks my heart to say this for what might be the last time, but good morning, DerbyCon. Woo! Appreciate you guys coming out so early. Come listen to us chat a little bit. I know the 9 a.m. slot's a little early. Did you guys have fun at Infected last night? That was awesome. That was awesome. Heck yeah. They did. Hear that guy. So if you're here, welcome. We appreciate you guys showing up. We're here to talk a little bit about some Unix privilege escalation, not underwater basket weaving. I believe that's down the hall and to the right. So,
all right. As he said, welcome. Thank you for coming out. Let's go ahead and do the little intros, who we are, all that, why you care that we're standing up here, I guess. I don't know. But my name is Adam Compton. I've been in InfoSec for pretty much my entire career, good number of years there. But over that time, I've done a little bit of everything. I've done pen testing, coding, research, a little bit of that. Currently, I work with David here over at TrustedSec. Go TrustedSec. But beyond that, I'm father, son, husband, hillbilly, all that. Yay, hillbillies. No, but no. No, honestly, born and bred back in eastern Kentucky in the mountains, all that. All my heritage there. So very good about that. Let's go over to David.
So like Adam said, my name is David Boyd. I'm also a consultant for TrustedSec. I'm a Christian, which just means that I'm a sinner saved by grace. Husband and father. I did some time in the Army. Big geek and gamer. And I've been hacking on stuff since I was much younger. And doing it officially for about the last 10 years.
I'm short. Sorry. Hey, that's better. All right. So, as David said earlier, we're going to be talking about Unix privilege escalation with a little bit of other Unix thrown in there over as we go along. So, what are we going to be talking about? We're going to be talking about Unix in general, a little bit of its history, more of this more common exploits you're going to see out there if you're going against them. This is not going to be a deep dive into Unix. It is not going to be like under the covers, deep in their driver development, stuff like that. This is more of an intro to Unix. Mostly this originated from the concept that I go to conferences, I read the online articles, I see the other talks, all that. So many people are focused on Windows. I understand. That's the majority of what we see out there as pen testers is Windows. That's right. Mostly what's on there. But inevitably, we always come across a Unix system here and there. Maybe it's the back-end servers. Maybe it's controlling some delicate application, something like that. But there are Unix out there on a lot of networks. On top of that, if you're doing CTFs, a lot of those happen to be Unix-based. So that's what we're covering here. Is like you're going to see it out there. Don't be afraid of it. Here's some common things to get you in the mindset for it, to get you started going down the road to doing more research, more attacks against Unix systems. So.
The thing to remember too, especially when you're on a pen test or you're doing a red team or something, is oftentimes we find a lot of our goodies on Windows systems, and for whatever reason Linux systems are just kind of overlooked or they're just kind of skated over. But there have been so many times when we found things like PHI or PCI data, credit card data, things like that, just sitting on essentially an open Linux system. Database is just chock full of passwords, all sorts of stuff. So hopefully this will help, take away some of the fear related to looking at Linux systems, Unix systems. Very cool. And also in terms of that debate about Emacs versus Nano, we all know that Nano's better.
Ed. All right. So we're going to just do a quick little run through for the history of it, just to give everybody a perspective of what Unix is. You're like Windows. Windows came out, it went through Windows 1, 2, Workgroup, 95, ME, yay. No, I'm kidding. 2000 all the way up to now. So, but what is the history of Unix? It dates back a little farther. We're going to start in the beginning of time here in 1945 with ENIAC. It started out, basically systems were created that led into Unix. Multics came around. There were some guys out there, Dennis Ritchie and Ken, that worked on Multics, decided that they liked it, wanted to start their own little thing. That came a little bit later. But first they created Well, actually, first they did create Unix on PDP 11s. Then came C, at which point it was completely rewritten, and then we started getting the other variants coming out, and there was a slew of those. You have BSD, System 3 came out, first public release outside of Bell Labs, and the floodgates was opened, at which point we had Sonos, HPUX, Ultix, AIX, IRX, Solaris, and it just went on. Let me step back here. That's a big one for a lot of us in here. That was 1991. That's when Linux version, what is that? 0.01 came out. Yeah. Yay. And that's what most of what we encounter now as far as Unix goes, with the occasional AS400 and those thrown in there. But most of what we encounter, most of what we use are Linux-based systems. But it kept rolling out. There's Digital, True, OSX, and yes, OSX is a Linux derivative as you go through it. Next little slide here. No, go ahead.
Yeah, so with all of this, right, and with this, essentially core operating system being open source, everybody gets to put their finger in the pie, right? Well, when you get a lot of fingers and a lot of different pies, you start to get a lot of different versions.
No, arrows, not shift.
There it goes. Yeah, so it starts to go, and then it goes, and then it goes, and then it grows, and it continues to grow over the years, and forks and mutates and continues to go and go until you get up into the thousands of different distros.
Easily thousands, yeah. It forks, migrates, merges back in. Some OSs disappear, new ones form, and then you get all the way up to modern day. And just for a full scope of it, let's zoom out there. This is the relatively full history of Unix. So a little more complicated, a little more background, a little more diversity in there from the Linux. So from Windows, I mean. So going back to the previous slide back there, way back, it's okay, don't worry. It's from Jurassic Park when it says, I know Unix. That's why so many people laugh at that, is that if you know all of Linux, that would be rather godlike, I would say, but still. But no, I have worked on a lot of Unix systems myself, but there's no way you can do this. What you do is you focus on those that you're most commonly going to interact with, which might be your Solaris, your Red Hat Linux, occasional BSDs thrown in there, and OSX. Outside of that, depending on your environment, you might have special requirements, but those are the ones that most of the exploits out there currently are going to be running on. And but yeah, so we're going to just be referring to Unix in general from this point on. There's going to be certain caveats, of course, if you dive into them, whether it's running on Solaris or it's running on BSD or OSX or whatever. But in general, all of this is going to hold true across the board. So you want this or me? All right. So over the history of Unix, there's been a few categories, general categories of where issues fall. And historically, passwords were a big one. Default passwords or weak password encryption or passwords stored in clear text, things of that nature. File permissions, always you have your all operating systems at this point, I believe, have some sort of file access list. Like, do you have permissions to read it, write it, modify it? Way back when, everybody was all trusting, so everybody can read and write everything. So over time, that's locked down more, but there's still issues out there with things like set UID, set GID, things of that. Trust relationships still exist, but we're going to go into a bunch of this with like the rlogin, RSH, Xhost, all that kind of stuff. We'll touch on a little bit. And then, of course, every OS has their own application flaws. We're talking unlike Solaris, you had like sadmin-D issues years back. You always have your Tomcat, your Jenkins, all that, which do run on Unix. I see about a 50-50 if it's running on Unix or Windows over time. So
yeah, the thing to keep in mind with all of this is, back in the day, folks were not really thinking about security when they were, setting up these systems and stuff, right? It was set it up, get it running, and then carry on. And especially with Unix systems, again, and you saw on that last slide, so trusting. With it being open source and all these people have stuck their fingers in the pie, then obviously it's got to be fine, right? Like only the sysadmin knows how to access the system, so it's good. He's got to get in there 3 or 4, 100 times a day. Let's not set a password, or let's set a shared password that a lot of people know, which then led into several other different security vulnerabilities, which then led into several other like really bad decisions in terms of setup. That from 10, 20 plus years ago, we still see even to this day.
It's all good. And of course, there's no talk on the history of Unix and vulnerabilities without talking about the Morris worm. We're going to talk maybe a minute on this. There's lots of research out there, entire books written about him and the worm. Go look it up. Fascinating read, the kind of things that he found, all that. But mostly, just summarize it though, he targeted flaws in the way that SendMail was handled, finger. You could enumerate with that RSH or ZAC, trust relationships again there, weak passwords. People like to use things like God or 123 or blank or whatever at the time. So it worked well. It spread, got out of control based due to a slight logic error that was in there. Go read about it. It's fascinating reading. And the fact that he released it at Cornell, even though he was working. He was a student or working at MIT at the time, just so it wouldn't be traced back to him. He went to another college to release it when he did. So it's kind of funny little read there. But yeah, happened back in 1988. I really recommend everybody just go read it if you want some quick reading on it, and it's a nice little look into the history of it. So jumping into passwords a little bit here. As we said before, in the beginning, Unix coming out of DARPA and all that was rather trusting. It was friendly. Everybody wanted to share. Everything was set up that way. So they didn't put too much concern on password security and all that. So, and over time, they had to start adding it in as it got larger, more people using it. And when they did is they created a file called Etsy password. I'm sure y'all have seen this. It's broken down into username, encrypted password, UID, GID, so forth. In the very beginning, for the longest time, I'd say early 2000s, even up through then, you would still see an Etsy password file there with the encrypted password still in there. You'll still see it on some other systems, some embedded systems. I still see it. All you do is if you have read access to that, which everybody on the system will have read access to Etsy password, you can download that, crack it, and move on your way. So they started correcting that, fixing it. They made the encryption on the hashing better, moved it up to SHA-1, SHA-256, and so forth as time goes on, and they pulled that out. Most Unixes pulled it out into a file called Etsy Shadow. So if you do manage to get a copy of Etsy Shadow, that's where your passwords are going to live for the most part now. Yes, HPUX, HPUX, and those actually have their own little security directory and separate files for various users and all that where they store their passwords. But in general, you're going to have Etsy password, Etsy Shadow. That's going to cover most of it. It's still relatively easy to crack a bunch of these because we're humans. We pick easy passwords. I rarely come across a scenario where there is a enforced password policy on Unix systems. Right. Whereas on Windows, you can say, oh, it has to be 16 characters long and all that. You can set that up on Unix, but the people who are setting it up on Unix tend to overlook that. They don't mind that. Well, because they're usually it's just the admin themselves using it or a very select group. They're like, we'll make good passwords. Yeah, it's going to be password 1. Yeah. So you can guess it, get in, stuff like that. So next thing then, hold on a second. Oh man, go if you want to talk.
Very good. Yeah. So again, password issues. That's definitely one of the things we see. Another one is file issues, right? So the way files are set up, when you look at file types and file attributes, you see -r and everything else. Each one of those has an actual like what it means. So your dash might mean the type, your R is the owner, then it goes to group, then it goes to other, right? And if you look at that, oftentimes you'll find things like set UID, set GID, or something like a sticky bit set in place. And if any of this, in terms of how it's set up, if any of this is set up wrong, then you could essentially get full read or write access to this file just because they had a bit flipped the wrong way. Sometimes the directory's owner, or even folks that don't have root user access can go in and rename the file and alter it because it wasn't set up correctly.
Yeah. Just one of the random things that you'll see out there occasionally that I've made use of in the past is you may go into a directory that you have read and write access to the directory, but you don't have read and write access to the files in it, just due to the way they set up their file permissions. But if you can read and write if you can read the directory, but you can't, if you can read the directory but not read the files in it, you can usually make a copy of it because of the way that file structures, inodes, and all that, the internal file system works on Unix. So you can still get access to those files. you have to think about layers. Like if somebody has access to a parent directory, they still can get access to the files within there. Yes.
So, and I'm a Unix dude.
Yeah.
So you're telling me if I see directory 1, I make copy of directory, I can read it, but I can't execute the files in it. I can make copy of directory 1 to directory 2, and then I can modify the attributes in directory 2.
As direct as that, no. But there are, no, there are steps that you can do that can gain you access to it if you do have permissions to read the parent directory the way that it's handled inside. It's not as a matter of fact, it's just copy -R this directory to this directory. Now I have it. At one point in time, it was that way back late 90s. You could do that. It's tightened down a little bit beyond that now, but there are still techniques you can do to gain access to those files. Maybe not directly copy them, but you can gain access to those files through there. And we can talk after the fact if you want to on that. But it's just one of those things that it's same with group policy and all that.
Yeah.
If there's a parent policy that gives you access to something, it may bleed down if you don't specifically restrict it, stuff like that. We can talk about it after the fact if you want to on that, but just be careful with your file directories and permissions and all that. They do stack in odd ways at times. So
yeah. And we'll be talking about we'll have a couple videos and stuff showing some of these techniques. But say you're on a Unix system and you're just kind of browsing around, glancing around, seeing what you can find. Some interesting files that you should take a look at are definitely etc password, your var log, var mail files, your .history, .r hosts, the .forward, any file with a little tilde symbol. Those are typically hidden files, but you can often kind of take a look at those. And then you want to start looking for things like set UID and set GID, which we'll show that here in just a second.
Sorry.
No, you're good.
Get back on this side here.
You want to say anything else?
No. I mean, basically, you look in the directory for anything that in your home directories that start with a dot. Yep. Those are generally your more important. They tend to have some sensitive files in there or sensitive information at times, whether it's history logs or what have you. So, a little bit of trust relationship here. You're not going to see this often. Maybe you'll see it in CTFs nowadays or systems that are rather old, but there's a file called .rhost. And in there was you could restrict it. You could say, okay, somebody could log in here using, or run commands on here using rlogin, rsh, rexec commands. And by default, they can come in and execute commands based on this file where you can say this user at this system has access to come in and run these commands. Or you could say only this user at any system or any user at this system. But because of the way it's set up with the plus signs, you could say any user at any system can come in and run commands. What that also means is they can do it without passwords. If they're allowed in the in the .rhost file, they can do it without a password. And a lot of developers and CTFs and all that, they tend to use this file. They'll be like, oh yeah, I don't know if I'm going to be this user on this system, I'm root on that system, so I'll just go ahead and throw a ++ in the rhost file and they can come in from anywhere. I have actually, not in the recent history, but I have gained access to Unix systems due to this. And it's generally not root that you gain access to, which is the super user. You gain access to standard user accounts, things of that nature. There's also an equivalent one called host.equiv, which is more global as opposed to a particular user. NFS, we're actually going to do a video on NFS here in a minute where you have to be careful on how you export NFS shares. There's precautions in a lot of Unices now that help regulate this, but if you are not careful on how it's being exported, people can mount it and overwrite whatever access controls you have on there due to mounting permissions. And then, of course, you have sudo, su, things of that nature where you do sudo-l on your system, see what files, what commands you have access to run. And it's the same as run as on Windows if you're not familiar with it.
And as a quick caveat to that, a couple side note is, during your initial enumeration scans, a couple ports to look for, 512, 513, and 514. That's rexec, rlogin, and rsh. If you see any of those open, those are usually something you got to just start poking at. So
let's go ahead and get started in here. We're going to do the first of all video. First thing, we're going to go off nmap this site. we're looking at some of the RPC stuff here. We see that RPC bind is up and running. We also see that our exec login and shell, NFS there, all RPC protocols. So we're going to do RPC info-P against the target. That'll give us some information about what versions of the programs are running for RPC and all that. We see rstat-d, ruser-d, going through a little history. No, this was a video. Yeah, you can go back and watch it later if you need to. We'll post it up there.
And then pause it right there.
All right. All right. All right. So what we did is we did nmap against the system. We saw that RPC info is out there. They're running on our users D, rstat-d, things of that nature. So we ran RPC info against it. We saw versions that were running out there. So then we went ahead and ran our users against that target. It is hit or miss on how many of the users it'll return to you, but it's usually the users that are currently active on the system. It'll return back to you depending on the flavor and version of Unix that you're looking at. In this case, it came back with MSF admin, root, and user. MS admin, yes, this is a Metasploitable that I was targeting here for the video for this. So I saw that, and then I saw, oh, okay, they have root, user, MSF admin. Then I went ahead and said, okay, let's try RSH or remote shell. -L is the login name I want to try. So I said, go ahead and give me root against that target, checking to see if they might have some weird permissions and rhost files, something like that might allow you in. In this case, it did. At the bottom of the screen there, you'll see that I ran ID once I got on the system. I'm showing that I'm setting at root right now. You're probably not going to see it as direct as this in a real world environment, but on CTFs, you probably will see something like this to get more experience and all that. I have done this exact thing on engagements. It's been a number of years ago, but I have done this on large organizations that have a lot of Unix systems, and there'll be those ones set on the side that are their development boxes, and those tend to be the ones that they set up like rhost files and stuff like that. Also with rhost files, when people started using SSH over rhost or over RExec and RSH, SSH can actually honor rhost files, and that's some weird ways in there. So typically that functionality has been disabled through config files now, but if it's an older system, you might still find a scenario with that where you can SSH with the same privileges as RExec and RSH was going to provide you.
So in just kind of in conclusion with that one, essentially, because something was set wrong with RSH, he was able to elevate from just a regular local user on the box to root privilege, which gives him full access over that box.
Another one here we're going to kick off. This one we're going to be looking at NFS, I believe it is. So we're doing an nmap here. I'll just pause it up here and keep it going, dude. So first thing we're going to do, we're going to kick off NFS nmap script looking for a NFS show mount command. Well, it's the script NFS show mount against the target on port 2011, which is RPC, and 2049, which is your NFS port. And I don't know where the mouse is over here, so go back. Give me this. There you go. All right, let's do this again. Let's go all the way back. Sorry. Okay, let's just let it go here. I'll just talk quickly through it. So let it go again. I really don't know where the mouse went here, but it's invisible right now. So yeah, let it go. It's scanning its way through. So you see that it's exporting /, which is the root file system. The star means it's exporting it to everybody. There's no restrictions. Like sometimes you'll see other IPs in there, other systems, which means that only people on that system can mount the file system. This one has a star, which says that anybody can mount it. So, where is that? Can I be cool again? There it goes. Sorry about that. A little technical difficulty here. So we saw that show mount was running, or that NFS was running.
It keeps pausing. Sorry, there it goes.
Yeah, okay. So now we're going to do show mount. Oh my goodness. Here.
No, I was just going to.
Okay. I'm going to go back and just let it play and talk through it now. Sorry, everybody. Stop touching it. Sorry. I love presentations. No, actually I do. It's just technical difficulties come up here and there. So I apologize for that. Let's step back through it real quick here. So we're doing the in-map scan again. We see that the show mount is there. We see NFS is open on there. So now we're going to do a command called show mount -E that will tell you, there you go, list of exports. It's a different way to do it if you didn't want to do it through in-map. You can also do show mount -A, which will tell you who has it mounted. But right here, so we're making a directory locally on our system called MNT, and then we're going to mount the remote file system to our mount point. Same as Windows shares, things of that nature as well. So now we've got it. We CD'd into it. And we're doing a directory listing in there. We even went into the root directory of there, which you realistically shouldn't be able to do. We created a file. It exists. We're showing that it has file permissions down there. We created it as root. And how is that possible? So if we go, we're also going to go look at Etsy Shadow. We shouldn't have access to Etsy Shadow, but due to the way that this is exported, we do. We're going to look at that right here in cat Etsy exports. That no root squash, that was enabled by default on a lot of Unix systems back in the day. And before that, that wasn't even an option. So when you export a file system in the remote system, they're expecting a standard user to mount it, things of that nature. But if you're root on your remote system, like you're a pen tester, you have your system, and you mount it as root, well, you can gain root access to the remote file system just to the way that the handling back and forth of NFS works. That's why, I forget what year it was, but it was early 2000s, I started seeing that root squash was enabled by default on systems, which says that you can mount this file system as any user, but if you try to do it as a privileged user, UID 0, it drops you down to a guest user instead that has like very limited resources. Mm-hmm. So, but here again, CTF and older systems or even embedded systems that might not be updated or they haven't went through the proper hardening guides, yep, you may still encounter this. Yep. So just keep an eye out there. That's one thing I do. When I see Unix systems, I see if there's any NFS exports. So I try to mount them all as root, see what happens, what privilege I have. And if I gain something, great. If not, I just move on, see what access I do have. So, all right. All right. So some of the services that you're going to want to look at out there for that can come into play if you're doing a pen test or targeting Unix systems is going to be Telnet, SadminD, SendMail, stuff like that, historically. We're going to talk about some more modern ones here after a while, but tools you can use to identify these are Nmap, whatever, but Nmap itself historically has had issues. We're going to do a quick little one with that due to the set UID bit that they had in there, but it was a fun one. That got removed a few years later on after he came out and said, why are y'all using this? You shouldn't have done this anyway. You shouldn't have installed it, but yeah. Lots of other apps out there, Tomcat, Jenkins, JBoss, PHP at MyAdmin, my website, any number of these web applications out there. Same issue that people have on a lot of other OSs, they tend to install them as root and let them run as root, which gives them certain special privileges. If you compromise them, if you get code execution, you're already a foothold on the system. But that's just that's more application exploits to get to the OS, but they do still exist out there. There's lots of other things out there. There's kernel-based exploits we're going to be talking about in a little while. Probably my favorite exploit of all time is the next one we're going to show real quick here. It's one I saw back around the turn of the century, early 2000s, but it still pops up periodically. And it's everybody affectionately called the telnet-elf user, or yeah. So we're going to go ahead and do a quick run through here. This affected certain versions of Solaris up through I forget what it was, like 7 or 8. But so what you do? You do an nmap of it. You see Telnet is open. It's running Solaris 9 there. You try to Telnet into it. There's a special flag you can use, like the -L to tell you what user, and then in quotes you do -elf and then a username. In this case, I did root, and it came back to said, sorry, not allowed for console access. So this time I'm doing -elf bin and typing in the IP, and it let me on the system. There was a flaw in Telnet that affected a number of different System 5 based systems at the time. Predominantly Solaris is what people were seeing it as, and why you can see it here, right there, that line, that console/dev All right, console equals /dev console. That's why I couldn't do that as root, but as bin, you can do that as any user on the system. I compromised so many Solaris systems back in the day, but I believe in the last, I don't know, 6 months to a year, you actually seen this again on an engagement. Yeah. Which I'm amazed about, but so these old vulnerabilities still keep popping up periodically over time. So just keep them in mind.
Yeah, they really do. And he wasn't kidding. You know, it was between 6 months ago or so. This 10-year-old plus vulnerability happened to stumble upon it and gave me root access on a box. Because again, a sysadmin fired up a Unix system, set it and forget it, and left it. Didn't go through to check security configurations. Had that misconfigured. And I had root access on a box that had quite a bit of super sensitive data. So let's talk about, we've gone through some of the history, and we've gone through some of the historical problems with it. So let's talk about how can we incorporate some of these historical problems, some of these security misconfigurations and things like that to try to, get a better foothold within Linux systems and move about the network a little bit better. As we go through these, essentially with the demo videos, what we're going to be doing is saying, okay, so now we've got a shell. And what that means is we've got a low privileged user access on a box. And, it's early in the morning. However, if you guys wouldn't mind, anytime you hear me say, so we've got a shell, if you guys could give me a big hearty turtle power, that would be awesome. So what do we need to do? We're on a Linux system. We've got a low privileged user access. What's the first thing we need to do, right? And what I often, tell people is kind of get a lay of the land. Start doing some basic enumeration. You want to figure out what kind of user you are. So who am I? Who else is logged into the box? Who are the different super users on the box? You want to see what kind of info you have access to. What can you do within the box? How can you move about? What can you see? And where can you go? Can you go, can you go throughout the whole box? Are you in a restricted shell? Different things like that. A couple of good commands to run once you've landed on a box as a low privilege user. Uname -a, that gives you the current kernel version. And there are a just plethora of different kernel exploits out there. I mean, you're going to see there's hundreds of them that are often one-click exploits to get you from a low privilege access to root access. env gives you an environment variable. pwd gives you your current directory. Oftentimes, you'll be in a directory that you weren't expecting. So you want to kind of get an idea about that. Who am I? History, cat history, different things like this. Occasionally, you will see clear text passwords in history. You absolutely will. sudo-l are commands you can run as sudo. Again, something might be misconfigured, so you can run something as sudo as a low privilege user. And then you want to check who's in the sudoers file, as well as, if nothing else, you can pull additional usernames from etc passwd. And that will at least get you a better idea of username nomenclature and how their usernames are set up. Now you can do all that manually, or there are several scripts out there that are written by different folks. There's linenum.sh, Linux priv checker, and then Unix priv check. All these are available on GitHub, and they're very loud. Okay, but if you've already got a shell in a box, you may not be worried about tripping anything. So these will often run several different commands and then give you a nice pretty output to go through and parse through. And we'll go through a demo of what one of those looks like. So this is going to be, I believe this is Linux proof checker. So we got a shell. Yes. And we're doing just some basic enumeration here. We're checking who am I? We're checking what directory we're in. Can we go to root? It says, nope, you can't go to root because you're not a root user, permission denied. So as pen testers, we like to, let me pause that real quick. Whoops. It's really hard to pause videos, by the way, on a Mac here. Okay. So as pen testers, it's always a good idea to work cleanly, right? We don't want to leave artifacts behind on systems. So you'll see in this video, I moved to dev shm. And that's essentially a Unix temp directory that clears itself out, when you reboot the machine. So we're checking to see if we have wget, so that way we can pull down a file. So we do have wget. So we're going to wget. We've set up a web directory or web server on our local system, and we're going to wget our enumeration script and put it on the box. We double check that it's on there. We make it executable with chmod. And then we run it. And it goes through and it starts just pouring out just tons and tons of information there. It gives us everything I said. It gives us the list of users. It gives us cat pass WD. Gives us the kernel version. The name of the system, different file types, dates, things like that, and that gives you just a plethora of information that you can often take and start doing some general Google searching and things like that to see if any of this is exploitable. You can look for things like we talked about, RSH and different security misconfigurations that you can take advantage of. You can see what's got it says users who can sudo without providing a password, different things like that, where different files are being stored, who has access to what, all sorts of interesting files. It'll tell you if things have sticky bit or set UID installed and different things like that. So stuff that would take several minutes to try to parse through, a script can do for you in a few seconds. And if you're in a hurry or you're trying to be stealthy, you can parse this to a text file, pull it off, and then analyze it later. So now you've got all this information. What do you do with it, right? Say you've got something like a kernel version now. You know what you're looking at. A great tool that's made by the guys at OffSec is the exploit database. And Kali Linux has this installed by default, or you can pull a database down onto your personal Linux box, whatever you want. And it's called Searchplate. And it is it's a command line tool that lets you search and parse your exploit DB and allows you to look for different exploits for whatever you may have, right? So it gives you the ability to look for, say, if you find a Linux kernel version, right? If you type that kernel version in, it will give you a list of ready-to-go exploits that you can just copy, paste, and run and try to see if you can escalate some privileges. So here, the command we've got is searchploit dirty. Which Dirty Cow is a really popular back in the day. It was a really popular privilege escalation exploit, and that gives you all the different versions that you can pull down there. Another good thing to look for while you're on a box is set owner user ID permissions. So SUID files. It's a type of file permission that's given to a file. When a program runs, it's supposed to inherit the access permissions from the logged in user. However, SUID will give them temporary root access or temporary elevated access to a file rather than to the file owner itself. So in simpler terms, users will get file owners' permissions as well as the owner UID and GID when they're trying to execute a program, right? Anything else you want to say about that?
Right. You don't actually become that user, but you become effectively that user. Yes. It's sort of like that run as command again on Windows, but when you actually have if you use a set UID to gain a shell or something like that, you'll see that your UID is not 0. Your EUID is 0. So your effective UID is you're still your standard user, but now you're running as somebody else. You're impersonating somebody else for that.
That's a great way to put it. Yeah, you're acting as somebody else impersonating them. So this is what kind of set UID looks like. So we've got a shell. Woo! And again, we've got a shell. We're going to start taking a look. Who am I? We're just MSF admin. We're going to do uname-r to take a look at that. And then we're going to start looking for files with set UID permission set. So that's the command for that find/perm 4000. And then we look through that list there and we go, okay, all right, well, we've got a couple different options here. And we see one that's that's Nmap, right? And this is what we were talking about before, is Nmap was installed on several versions of Unix by default. Unfortunately, it wasn't installed correctly, and it was installed with that set UID bit set.
Right.
So again, pen testers, we work cleanly. We're going to go to dev.shm and write a simple shell script to execute bin.sh as essentially you give us root access. So we see that we've written the NSE script, which is the Nmap scripting engine for Nmap. We're going to run our shell script that we made. We're going to move from being a low privilege user all the way up as root with 2 lines of a simple shell script because Nmap wasn't set correctly.
There's an easier way.
And now, yeah, and so that's if you wanted to do some simple shell scripting, or you could just run Nmap as an interactive mode, and you move from just a regular low privilege user up to a root user. Yeah,
you move up to whatever user Nmap is owned by, and typically Nmap
was always owned by root. So they kind of fix that later, but
you can still do the interactive with the shell commands from Nmap. You just the set UID is missing, right. So you're just running it as yourself. So there's not really much point to it, but I'm sure there was a reason at some point he put that in there. I don't know, but yeah, it was always a fun one when you come across that.
Yeah. So again, if you see Nmap installed on a Unix system, just try to run it in interactive mode or write a simple bash script. You'd be surprised at what you can do. Another one here. So a really popular way to escalate privileges within Linux systems is through what's called kernel exploits, right? And those take advantage of out-of-date kernels, which is the core of what makes up a system. Some of the more popular ones were Mempo Dipper, Dirty Cow, Send Page, and then a recent one that came out just this year, this spring, was called Dirty Sock. And they essentially, a lot of these are essentially set it and forget it, right? One command or a couple commands, and then you move from a low privilege user who has no access and shouldn't be able to do anything on the box to full root user access. Really popular one back in the day was called Dirty Cow. It came out in 2016, I believe. So it's not really that old. This is, we're only talking about a few years here. And it takes advantage of the kernel's memory subsystem on the copy on write. That's where the cow comes from. Breakage of read-only memory mappings.
We keep saying that some of these are a little older, but like 2016 isn't that old for Unix. Windows it is a little bit, but the thing is you have to understand there's a mentality among a lot of system administrators for Unix in that they are obsessed with uptime. I was when I was a Unix administrator too. You like to have multiple year uptimes if you can. Updating the kernel requires a reboot. So that's one of those things that you'll probably see older versions of kernels out there, unless they're in a shop that requires them to do that by law or something like that. The administrators are going to just usually install it, leave it alone, just because any change to it is going to affect the stability of the system possibly, or require them to reboot. Yep. And like I said, I don't understand why that mentality is in there. I had it myself, but people love having those triple-digit, quad-digit uptimes in there if you can, and it's just amazing. So
yeah, it really is. Essentially, what in layman's terms, what this took advantage of is a regular user could take advantage of this flaw and gain write access to boxes that should only have read access. Okay. Here's a list of the kernel versions that were vulnerable to this, and these are all still relatively recent. And several of these we still see out in the wild even today. Like even just last week, I think I saw 1604 with that kernel version on it, and I was like, holy cow! So this is kind of what Dirty Cow looks like. So on this box, we got a shell. Woo! Is it going to play? Is it going to play? Aha, there it goes. Okay, so check an ID. We are not root at this time. We're just hype, I think the hype user. So we're going to do uname-r, and we see that kernel version is vulnerable to Dirty Cow, looking on that past list, right? And we're going to check the LSB release there. We see it is Ubuntu 12.04. So we're going to do a search exploit for Dirty. We find an exploit there written in C that seems, relatively easy to use and relatively, what's the word? Relevant. So we're going to copy that exploit down, set up our web server. We're going to go back on the box and curl that exploit from our web server onto the box itself, so the one we're hosting. We've got it. We've now got it in on the user system essentially. Oftentimes with these exploits, they will have compiling instructions built into the README. So you just look at the compiling instructions. Oftentimes you can just copy and paste it. So we're going to compile it. We're going to run it. It runs through its deal there. It tells you, hey, what kind of password do you want? Here's the user that it's going to create. So the user, unfortunately, the guy's name was Firefart. He's the developer of one of them. So he essentially created the user Firefart, backed up their old Etsy Pass WD, and now you're that user Firefart, which is a root user with the password that you set. So you SU, which changes you over to the user Firefart with the password you've got, and now you're root. So,
but it's still that UID 0 is what
yes,
you're looking for.
Yeah, your UID 0, which is root, and again, you went from a nobody, from just a nobody user, all the way up to root with 2 commands.
One thing I would say here is because this process does actually make a backup of the old Etsy shadow file and Etsy password. When you've got to this point, copy those back over, because otherwise it's a definite telltale when they try to log in there and they're logging in as root for whatever reason, but they do, and their password doesn't work anymore. It's because you haven't moved to clean up after yourselves.
Yeah.
You can always redo this later if you wanted to, so it doesn't cripple the box. It doesn't do anything. You could always regain access. And once you're root, you could always make another backdoor of persistence of some other way. Yeah. So you get in, you copy it back over. Yeah. And don't leave logs and all that, but yes. Don't
leave things laying around for sysadmins to try to go back and clean up after you. And don't lock your sysadmins out, because if you're on a pen test, we want to, always try to remain professional, and we don't want to upset anybody.
Yes.
Another one was Dirty Sock. This one came out this spring. This is the one we were talking about. It takes advantage of a bug in the Snap AD API, which is a default service installed on many versions of Linux. It affects all versions of Snapd less than 2.37.1. And as of spring 2019 of this year, that was what was mostly installed. So again, with Dirty Sock, we do our ID and uname-a, kind of figure out what's on the system here. We want to check the snap version. That's another command you can run. So you check the snap version. We see that it is a vulnerable version. And again, we're just a user florist. So we're going to do a little bit of Googling and see if we can find, a Dirty Sock exploit with the exploit database.
Could have done that with SearchBoy.
You could have done that with SearchBoy. 6 one, half dozen the other. Right. So we're going to pull down this nice little Python script that runs this Dirty Sock exploit. Set up our web server so that way we can host it and pull it down onto the local box there. CD to dev SHM, so that way we work, and can clean up after ourselves. Use a wget file to pull that file down that we're hosting on our local web server. It's a simple little Python script. And then we're literally just going to run it. Gives you a nice little graphic, goes through and tells you everything that it's doing. Takes a few seconds. Dirty Sock's kind of neat because it'll sleep for a few seconds after each command so you don't overload the system. And it says success. You can now SU to the following account and use sudo, which is for root permissions. So you SU as Dirty Sock, type in the password, which is Dirty Sock. And now you see you've gone from Florist to Dirty Sock. And if you type ID, you are now essentially you're not root yet. That's right. You got a sudo to bash. And then when you type ID, you are now root. So you've essentially gone with 2 commands from the Florist user all the way up to root.
What it does, effectively, for anybody who's concerned, it uses the Snapd API to make a few changes. It creates a new user called Dirty Sock, and then it also adds it to the Etsy sudoers file to give him ability to run bash. Yeah. As elevated. So you do one step to gain access to the new account, then another one to gain root. So, yes.
A couple of final thoughts. So if you want to go to the house and practice any of this stuff, there's plenty of resources out there. Got Milk kind of started the whole thought process on privilege escalation back in the day. So go read his blog in 2011. We also like throwing out other talks in there of folks that have done some stuff. So besides Augustus, Jake Williams did a talk, as well as the Tradecraft Security Weekly podcast. And then if you want to try it at home in your own home lab, there's Hack the Box, which is a great environment for you to learn in. VulnHub has plenty of vulnerable VMs for you to practice on. You just download them locally, practice on them, beat on them, as well as Metasploitable. That's kind of the great starting point to learn and practice, and it's a really easy one. There's plenty of guides and walkthroughs. And do not feel bad about using a walkthrough if you're just starting this and new to this. Do not feel bad about using a walkthrough to go through and kind of learn and kind of get a feel for how some of this works. because oftentimes there'll be different paths that even we've missed that we've looked at and go, oh, okay, that's a different way to look at it. So with all of that being said, we sincerely appreciate you all coming out. There's our contact information. We love you guys. Thank you so much for coming out and hanging out with us. Does anybody have any questions?
Within the next couple hours, slide deck will be up on SlideShare or something like that. I'll send out a tweet. I guess you'll send out a tweet as well. If you want to get a copy of it then. All of our contact is here. Reach out to us if you have any questions, comments, whatever. So thank you.
Comments, concerns.
Thank you.
Appreciate you guys. Thank you so much. Thank you, DerbyCon.